I'm doing this on the computer, so it's gonna probably look a little bit different than what you're doing. So I already have my lines and everything ready to go. So the first step, we want to triangulate the epicenter of the earthquake. So we need the arrival times of the primary or the P wave and the secondary wave to 3 different locations. So I'm going to demonstrate how to do it with Balboa Heights in Panama. So as I said, I already have my lines ready to go. So the first step is to draw a line from where when the primary wave was received down to the timeline, and then draw a line from when the secondary wave was received or felt down to the timeline. So now I have my times. If you look, there's 15 minutes and here's 20 minutes. So each one of these is a 1-minute increment. So the P wave arrived around 19 minutes. And the S, or the secondary wave, arrived just before 24 minutes, so we'll say 23.75. And so I go ahead and enter that in my data table, and I've already done that. So we got 19 minutes when the P wave arrived, 23 minutes and 23.75 when the S wave arrived. And let me change that. I have a colon instead of a decimal. It's 2 different times. So then you just figure the difference, being a subtraction problem. So 23.75 minus 19 is 4.75 difference. So now we need our graph. So this is already pre-established, so you can see the curves for the S wave and the curve for the P wave. So you want to, you could do this on paper. You start at the origin, or 0, on the y-axis, and you want to measure a line, and you could just mark it off on a piece of paper. We want to get the distance, or the length, between 0 time and approximately 4.75. So I got my line. So now I want to move this, or you can move your paper with the little tick marks. And you want to see where these lines are approximately this length apart, and it looks like right about there. So I'm just going to follow this down to the x-axis, and we're going to see our distance to the epicenter, and this is in kilometers, or it's the number times 10 to the 3rd power, which basically you just add 3 zeros. So this looks like about 3,250 kilometers. And I've already entered that. Let's see if that's what I had. Yeah, 3,250 kilometers distance to the epicenter. So now we need our map, and we go to that, and I've already established. So I'm obviously not using the compass on the computer, so I've just established a circle. So you want to use your scale at the bottom. You're going to set the middle of the compass on 0. Okay, and then your pencil or your pen, you're gonna draw that out to approximately 3,250, and now we can use this, and we'll place this over Balboa Heights. And so what this tells us is that the earthquake originated some point 3,250 kilometers from Balboa Heights in Panama. We don't know exactly where. This point is 3,250 kilometers away from Balboa Heights. This point here is 3,250 kilometers from Balboa Heights. Every point along the circle is that distance from Balboa Heights. That's why we need 2 other locations to see the distance from those, and where the 3 circles meet is where the earthquake or the epicenter originated from.